We are going to discuss about industrial hygiene. Industrial hygiene is the science and art devoted to recognition, evaluation, and control of environmental factors or stresses arising in or from the workplace, which may cause sickness, impaired health, and well-being, or even exposure to chemicals and hazard materials to the workers and citizens of the community. First and foremost, recognition of occupational health hazards. There are classifications of occupational health hazards, and the various environmental stresses or hazards, otherwise known as the occupational health hazard, can be classified as chemical, physical, biological, or ergonomic hazards. The first among classification of occupational health hazards are chemical hazards, which arise from inhaling chemical agents in form of vapors, gases, dust, fumes, and mist, or by skin contact with these materials. Risk of handling a given substance is dependent on the magnitude and duration of the exposure. An example of these chemicals are gases or substance in gaseous state or airborne at room temperature. Example are chlorine, hydrogen, sulfide, ammonia, carbon monoxide, sulfur dioxide, phosgene, and formaldehyde. Another is vapor, results when substances that are liquid at a room temperature evaporate. Example are components or organic solvents such as benzene, toluene, acetone, and xylene. Another example is mist, a fine particle of liquid float in air, particle size up to 5 to 10 micrometer approximately. Example is nitric acid and sulfuric acid. Dust is also an example. A solid harmful substance are ground, cut, or crushed by mechanical actions, and fine particles float in air. Particle size about 1 to 150 micrometers. Example of these are metal dust and asbestos. Fume is a gas condensed in air, chemically changed and become fine solid particle which floats in air. Particle size about 0.1 to 1 micrometer. Example are oxides generated from molten metals such as cadmium oxide, beryllium oxide, and others. Another example of occupational health hazards are the physical hazards. It is related to problems such as extreme of temperature, heat stress, vibration, radiation, and other things that can hurt or harm to us. It is important that employer, supervisor, and those responsible for safety and health are on guard to these hazards due to the possible immediate or cumulative effects on the health of the employees. An example of a physical hazard is extreme temperature. Extreme temperature or extreme heat and extreme cold affect the amount of work that people can do and the manner in which they do it. In industry, the problem is more often high temperature rather than low temperatures. Heat stress makes be experienced by workers exposed to excessive heat arising from work. Workers at risk of heat stress include outdoor workers and workers in hot environment such as firefighters, bakery workers, farmers, construction workers, miners, boiler room workers, factory workers, and others. Workers aged to 65 and older, with those with heart disease, hypertension, or those taking medications are at risk of greater heat stresses. Factors that influencing heat stress. These are include air temperature and air humidity. Another is air velocity, radiant temperature, clothing, physical workload, whether light, moderate work, or heavy work. Another example of physical hazard is radiation. It came from electromagnetic waves that produced by the motion of electrically charged particles. These waves are also called electromagnetic radiation because they radiate from electrically charged particles. They can travel through empty space as well through air and can penetrate some other substance. Radio waves, microwaves, visible light, and X-rays are examples of electromagnetic waves. The electromagnetic spectrum can be divided into two at a wavelength of 10 nanometer, which distinguish non-ionizing radiation and ionizing radiation. There are types of non-ionizing radiation. Example of this is ultraviolet radiation, infrared radiation, laser radiation, and microwave radiation. Extreme pressure is another example of physical hazard. It can be encountered by those workers that are working in a hyperbaric environment, like divers operating underwater, whether by holding the breath while diving, breathing from a self-contained underwater breathing apparatus or scuba, or by breathing the gas mixture supplied by the compression from the surface. Working in extreme pressure are greater risk. In some cases, some divers are becoming deaf, or some are losing their ability to walk by diving to the extreme pressure environment. Another example is inadequate illumination. The measure of stream of light falling on the surface is known as illumination. The key aspects of illumination include lux, luminance, reflectance, glare, and sources of lightning. There are key aspects of illumination. Lux, a unit of measurement. Luminance, measure of light coming from the source. Reflectance, ability of a surface to return to light. Glare is caused by the bright light source which is caused by seen looking in the range from straight ahead to 450 above horizontal. There are two types of glare, direct and reflected. Direct glare is produced when the light is positioned at the surface. It can be prevented by correct installation of light fittings, installing louvers below the light source, and closing the lamps in a bowl reflectors and opaque or prismatic shades. And reflected glare is produced when the light is reflected of a shiny surface. It may be addressed by providing indirect light. Another thing is sources of light. There are two sources of light. Daylight, also called natural light, depends on the availability at the location and weather condition. Another is electric light, came from incandescent bulb or bulbs, fluorescent lamps or tubes, high intensity charge or mercury. There are types of lighting. Illumination can also be used in terms of general lighting illuminating the entire premises, local lighting, direct light in a particular object or working with. Factors in determining the quantity of light. Nature of work, more light will be required if one is working with small objects. Environment, the ability of surrounding surface to reflect light. Eyesight of the workers, the ability of eye to adjust rapidly to environment distances declines as people grow older. Another example of a physical hazard is excessive vibration. A body is said to vibrate when it is in oscillating motion about a reference point. The number of times a complete motion takes place during the period of 1 second is called frequency and is measured in hertz. Vibration usually refers to an audible acoustic phenomena which are recognized by through touch and feeling. It is a vector quantity described by both magnitude and direction. The last example of a physical hazard is noise. The unwanted sound is a form of vibration conducted through solids, liquids, or gas. The level of noise in industrial operation can constitute a physical hazard to the exposed workers. The extent of a hazard depends not only on the overall noise but also on the time, duration, and the frequency of the noise to the exposed worker. There are types of noises. A continuous noise. It is a steady state noise with a negligible level fluctuation during the period of observation. Intermittent noise. Their level shifts significantly during the observation. Impact noise, which consists of one or more bursts of sound energy, each lasting less than 1 second. The factors that can influence noise exposure. A number of factors that can influence noise exposures. There are variation in individual susceptibility, the total energy of the sound, the frequency and distribution of sound, other characteristics of the noise exposure such as whether it is continuous, intermittent, or made up of series of impacts. And last, the total daily duration of exposure.
For the number 3, biological hazards. Biological hazards are any virus, bacteria, fungus, parasite, or living organisms that can cause a disease in human beings. They can be a part of the total environment or associated with certain occupations such as medical profession, food preparations and handling, livestock, raising, and etc. Number 4, ergonomic hazards. The applications of human biological science in conjunction with the engineering sciences to achieve the optimum mutual adjustment of man's sick and his sick work. The benefits being measured in terms of human efficiency and well-being. The ergonomics approach goes beyond productivity, health, and safety. It includes considerations of the total physiological and psychological demands of the job upon the worker. It deals with the interaction between humans and traditional environmental elements as atmospheric contaminants, heat, light, sound, and all tools and equipment used in workplace. These are the 5 examples of ergonomic hazards. 1. Poor workplace design. crop leg area, crowded workable distinct work materials. 2. Awkward body posture, prolonged sitting, twisted body while bending. 3. Repetitive movements, swelling, cutting, stamping, static posture, prolonged standing without motion. And number 4, forceful motion, extreme pulling and pushing. Number 5, manual handling, improper carrying of materials, use of pliers. In a broad sense, the benefits that can be expected from designing work systems to minimize ergonomic stress on workers are as follows: more efficient operation, fewer accidents, lower cost of operation, reduced training time, and more effective use of personnel. Number 5, the special considerations. The following items have become important occupational safety and health issues that need to be addressed by industrial hygiene professionals and employers. A. Confined space is an enclosed or partially enclosed space. It has restricted entrance and exit by location, size, and means. Thus, the natural airflow is limited. This can cause accumulations of dead or bad air and airborne contaminants. Confined spaces are not designed and intended for human occupancy. Hazards of confined space. Oxygen deficiency. Air is considered oxygen deficient when the oxygen content is less than 19.5% by volume. Oxygen level in a confined space can decrease due to consumption or displacement by inner gases such as carbon dioxide or nitrogen. Work processes such as welding, cutting, or brazing, and certain chemical reactions such as rusting and bacterial reaction, fermentation can also reduce oxygen concentration. Flammable, explosive atmosphere may result from oxygen-enriched atmosphere exists where oxygen in the air is greater than 21%. An oxygen-enriched atmosphere where caused flammable materials such as clothing and hair to burn violently when ignited. Flammable gas, vapor, or dust in proper proportion. Toxic atmospheres are those which contain toxic substances and concentrations that exceed the threshold limit value 90 lV as specified in the Occupational Safety and Health Standards or the Chemical Material Safety Data Sheet of the substance used at work. Mechanical and physical hazards. 1. Rotating or moving mechanical parts or energy sources can create hazards within a confined space. 2. Physical factors such as extreme temperatures, noise, vibration, and fatigue. And 3. Loose materials such as fine coal, sawdust, or grains can engulf or suffocate the workers. An example of confined space with its accompanying occupational health hazard. Letter B. Indoor air quality or IAQ refers to the quality of the air inside buildings as based on the concentrations of pollutants and thermal temperatures and relative humidity, conditions that affect the health, comfort, and performance of occupants. Sources of indoor air quality problems: ventilation system deficiencies, overcrowding, tobacco smoke, microbiological contamination, outside air pollutants, off-gassing from materials in the office, furniture, and mechanical equipment, poor housekeeping. Indoor air pollutant, volatile organic compound or VOCs, formaldehyde, carbon dioxide, carbon monoxide, nitrogen oxide, sulfur dioxide, ammonia, hydrogen sulfide, and dust. Other factors affecting occupants: comfort problems due to improper temperatures and relative humidity conditions, poor lighting, unacceptable noise levels, adverse ergonomic conditions, and job-related psychosocial pressures.
Letter B. Methods of recognizing occupational health stresses or hazards. Number 1. Walkthrough or ocular inspection. This is necessary in identifying the potential hazards and determining the critical conditions in the workplace. It will be good to make a checklist for inspection. Number 2. Review of the process involved. The identify of the chemical intermediates formed in the course of an industrial process and the toxicological properties of these intermediates may be difficult to establish. Undesirable chemical byproducts such as carbon monoxide resulting from the incomplete combustion of organic material may be formed. Number 3. Knowing the raw materials, byproducts, and finished products. Knowing about the raw materials used and the nature of the products manufactured will help you determine the specific contaminants to which workers are actually exposed. Possible impurities in raw materials such as benzene and some solvents should be considered. Number 4. Gathering workers' complaints. The actual chemical of the substance handled may be determined by interviewing the workers. More so, their compliance can also be gathered and assessed in the clinic record. Number 5. Safety Data Sheet or SDS is a summary of important health, safety, and toxicological information on the chemical or the mixture ingredients. It should contain A. Identification, B. Hazards identification, C. Composition information on ingredients, D. First aid measures, E. Firefighting measures, F. Accidental release measures, G. Handling and storage, H. Exposure control or personal protection, I. Physical and chemical properties, J. Stability and reactivity, K. Toxicological information, L. Ecological information, M. Disposal consideration, N. Transport information, O. Regulatory information, and P. Other information. The SDS should conform to the Globally Harmonized System or GHS of classification and labeling of chemicals. The GHS is an international standard for classifying chemicals and communicating its hazards. It is a basic for establishing a comprehensive national chemical safety program and a comprehensive approach to defining and classifying hazards and communicating information on labels and safety data sheets. The GHS was developed in Agenda 21 of the United Nations Conference on Environment and Development or UNCED held in Brazil in 1992. Benefits of GHS. All countries, international organizations, chemical producers, and users of chemicals will benefit from the GHS as it will. The benefits of GHS is to enhance the protection of the humans and environment, facilitate international trade in chemicals, reduce the need for testing and evaluation of chemicals, assist countries and international organizations to ensure the sound management of chemicals. The elements of GHS. Letter A. Hazard classification criteria. It has three major hazards group, namely physical, health, and environmental hazards. Based on the three classification of hazards, the following composed the GHS criteria. First is the physical hazards: explosives, flammable gases or aerosols, oxidizing gases, corrosive to metal, substance, and mixtures which, in contact with water, emit flammable gases, and others. Second is the health hazards. Acute toxicity, skin corrosions, irritations, serious eye damage, irritation, respiratory or skin sensitization, carcinogenicity, reproductive toxicity, aspiration hazards, and others. The third is the environmental hazards. Hazardous to aquatic environment hazard or hazardous to the ozone layer and others. Letter B is hazard communication, composed of safety data sheets, SDS, and labels. GHS labels must include specific signal words, warning or danger, hazard statements, flammable liquids, fatal if swallowed, symbols or pictograms. The evaluation of occupational stresses or hazards. A. Determining the magnitude or level of hazards using industrial hygiene equipment through work environment measurement or WEM. Once the hazards have been recognized, it is necessary to measure the levels of the hazards and the magnitude of workers' exposure to them. This is done through the WEM, which employs direct measurement of hazards. WEM is conducted for the following purposes. First is determine the magnitude of harmful environmental agents. Second is physically check the environment through measurement. The third is predict harmfulness of new facilities, raw materials, production processes, and working methods. The fourth is monitor workers' exposure to the harmful substances. The fifth is evaluate the effectiveness of environmental control measures adopted to improve the workplace. And the sixth is maintain favorable environment conditions. There are three types of environmental monitoring. These are the personal monitoring, the area or environmental sampling, and the biological monitoring. So, the first is personal monitoring. The measurement of a particular employee's exposure to airborne contaminants. The measuring device is placed as close as possible to the contaminant's entry port to the body. For example, when monitoring a toxic air contaminant, the measuring device is placed close to the worker's breathing zone. The data collected closely approximates the concentration of the contaminants to which the worker is exposed to. Number two is area or environmental sampling. Environmental sampling is the measurement of contaminant concentration in the workroom. The measuring devices is placed adjacent to the worker's normal workstation or at fixed locations in the work area. This kind of monitoring does not provide a good estimate of workers' exposure but helps to pinpoint work areas with high or low exposure levels of contaminants. The instruments used to measure the different hazards are lux meter for illumination, psychometer for humidity, anemometer for air movement, smoke tester for air direction, globe thermometer for heat, and sound level meter for noise. Number 3 is biological monitoring. Involves the measurement of changes in the composition of body fluids, tissue, or expired air to determine absorption of a potentially hazardous material. Examples are measurement of lead and mercury in blood or in urine. It is best that WEM be conducted on a regular basis. Work environment monitoring should be done at least once a year.
The next step of evaluating occupational stresses or hazard is analysis of results. The collected samples from the WBM or work environment measurement are analyzed in the laboratory. The different analytical instrument was used in order to have the results. And these are UV-VIS spectrophotometer for analyzing acids, AAS or atomic absorption spectrophotometer for heavy metals, gas chromatograph for organic solvents, X-ray diffractometer for mineral dust, Fowler transformed infrared spectroscopy and phase construct microscope for quantitative and qualitative analysis of asbestos and silica, and high-performance liquid chromatograph for inorganic chemicals. And the third process or part of evaluation of occupational hazard or stresses is comparison of measurement results with standards. Laboratory analysis results are compared with the threshold limit values, or what we call TLVS. These are exposure guidelines that have been established for airborne concentration of many chemical compounds. Concentrations of hazard that exceeds the TLVS can cause adverse effect to humans. There are three categories of TLVS, such as time-weighted average, short-term exposure limit, and ceiling. The first category is time-weighted average. Time-weighted average is the time-weighted average concentration for a normal 8 hours workdays or 40 hours work weeks to which nearly all workers may be repeatedly exposed day after day without adverse health effects. As you can see, we have here the formula in solving time-weighted average. The formula is TWA concentration is equal to C1T1 plus C2T2 plus CNTM over T1 plus T2 plus Tm, whereas C1 or Cm is a different mass concentration obtained at different sampling time, while T1 or Tn is a sampling time. Second category is short-term exposure limit. It is the maximum concentration to which workers can be exposed continuously for 15 minutes without suffering from any of the following. A is irritation, B chronic or reversible tissue damage, and C narcosis of sufficient degree to increase the likelihood of accidental injury, impair self-rescue, or materially reduce work efficiency. The third and the last category is ceiling. It is the concentration that should not be exceeded during any part of the working exposure. Otherwise, the exposed workers might be vulnerable to serious risk. And we have here the different threshold limit values tables. Things to remember. The impact of hazard exposure depends on the following: nature of the material or energy involved, intensity of exposure, duration of exposure, and individual susceptibility. The key elements to be considered when evaluating a health hazard are: how much of the material in contact with the body cells is required to produce an injury, the probability of the material being absorbed by the body to result in injury, rate that airborne contaminants is generated, total time in contact, and control measures in use. The TLV conversion equations for part per million ppm to milligram per cubic meter or mg over m cube at standard temperature and pressure. TLV in ppm is equal to TLV in mg over m cube times 24.45 over gram molecular weight of substance. TLV in mg over m cube is equal to TLV in ppm times gram molecular weight of substance over 24.45. Occupational Safety and Health Standards Rule 1070. Rule 1070 is OSH standard for occupational health and environmental control. It has 7 rules. First is Rule 1071, General Provisions. This rule establishes TLVS for toxic and carcinogenic substances and physical agents which may be present in the atmosphere of the work environment. TLVS refer to airborne concentration of substances and represent conditions under which it is believed that nearly all workers may be repeatedly exposed daily without adverse effect. Second and third rule are Rule 1072, TLVS for airborne contaminants, and Rule 1073, tables. This refers to TLVS of airborne contaminants for time-weighted concentration for an 8-hour workday and a total of 48 hours of work exposure per week. TLVS tables for airborne contaminants, mineral dust, and human carcinogens are also established. Fourth rule is Rule 1074, physical agents. This refers to TLVS for physical agents, particularly noise or sound pressure, that represent conditions under which it is believed that nearly all workers may be repeatedly exposed without adverse effect on their ability to hear and understand normal speech. Fifth rule is Rule 1075, illumination. All places where persons work or pass or may have to work or pass in emergencies shall be provided during time of use with the adequate natural lighting or artificial lighting or both, suitable for the operation and the special type of work performed. Sixth rule is Rule 1076, general ventilation. This is about general ventilation that encompasses the workroom condition for air supply, temperature, humidity, and odor. It states that suitable atmospheric conditions shall be maintained in the workrooms by natural or artificial means to avoid insufficient air supply, stagnant or vitiated air, harmful drafts, excessive heat or cold, sudden variation in temperature, and where practicable, excessive humidity or dryness, and objectionable odors. And the last rule is Rule 1077, Work Environment Measurement. WEM shall mean sampling and analysis carried out in respect of the atmospheric working environment and other fundamental element of working environment for the purpose of determining actual condition therein. It is also includes the responsibility of the employer that WEM shall be performed periodically as may be necessary but no longer than annually. Industrial hygiene is also concerned with the development of corrective measures to control hazard by reducing or eliminating the exposure. These control procedures may include: first is engineering controls, such as substitution of harmful or toxic materials with less dangerous ones, changing work processes, and installation of exhaust ventilation system. Second is administrative controls, such as safety and health policies and programs. Third is provision of personal protective equipment like earplugs, face shield, and dust masks.
First, we must study the noise pattern to be able to note the kind of noise, whether continuous, intermittent, or impact, that is generated. Then determine the number of hours of exposure of workers. The noise reading is then compared with the permissible noise exposure level, prescribed in Table 8P of Occupational Safety and Health Standards.
Yes, there are suppliers of industrial hygiene instruments locally. Here in the Philippines, we have the Umaga Safety and it is located in Manila, and the Arayim Trade located in Cainta, Rizal.
Yes, there are private service providers that conduct work environment measurement, but the OSH or Occupational Safety and Health Standard requires a work environment providers to be credited.
A WEM shall be conducted periodically as may be necessary, but not longer than annually. As required by the OSHS, WEM shall include temperature, humidity, pressure, illumination, noise, ventilation, and concentration of substances and chemicals. It is important to recognize environmental hazards or stresses in the workplace. The magnitude or level of hazards can be accurately determined by using industrial hygiene equipment. Prevention is better than cure, so it is necessary to assess and evaluate these hazards.